Today we'll talk about making a concentration of something that's heavier concentrated into something that is lighter concentrated. 9 times out of 10, we would think of this as our dextrose math, or C1V1 times C2V2. That's the math we'll talk about. And one of the reasons I never understood this is because there was no visualizing what the math means. And I had never done this in school or in reality, so it didn't make any sense to me. So we'll try to talk through, first of all, what the VTNE will say on its questions, on its math questions, and then we'll talk through how do we visualize this so that it makes more sense. So the question is, using a 500 ml bottle of 70% dextrose, how many mils will you add to 900 mils of LRS to make 7% dextrose solution? Okay, so where do we start with that? Let's first try to visualize a 500 ml bottle of 70% dextrose, which is what we're going to buy. 70% should be a trigger for you that tells you that is heavily concentrated. And we would never give somebody 70% dextrose straight out of the bottle. We would never do that. Even in an emergency, when an animal is super hypoglycemic, it is not registering on the blood glucometer, we still are not straight up giving it. We are diluting the 70% dextrose, or on this bottle it says 50% dextrose. Either way, we are diluting it. So that's your trigger. If it says 70%, dextrose, we know we have to take a small amount of that 70% dextrose out of this bottle, and we will add it into this fluid, your LRS, your lactated ringer solution, to make a dilution. So that's the first part you want to think about. Where is the big number? And then where is the smaller number? And by that, I mean, what is the other concentration? What's the other percent? So we're going from 70% to 7%. And you want to find like for like in this problem, because down here, when you have C1V1 times C2V2, the C stands for concentration. So one of these concentrations, the 70%, and the other 7% fill in two parts of our equation. That's why we want to learn about that. And since we are making a new concentration that will be less than the original, that's what this is asking you to do, to dilute the heavy concentrate into a diluent like sodium chloride or LRS or norm R or whatever they're asking you in the question. What are you diluting it into? In this case, you're diluting it into LRS. That's what we're diluting it into. Okay? So once again, if we start visualizing this, it's saying, the question is saying, I have a 500 ml bottle of 70%. Now, part of this question is super irritating because, sorry that keeps popping up. I know my screen doesn't support that action. Whatever, I just want to erase some things. It says it's a 500 ml bottle of 70% dextrose. It's throwing in, the VTNE question is going to throw in this 500 ml bottle nonsense, because this bottle of dextrose is literally 500 mils. That is what you buy from your vendor so that you can have it on the shelf waiting to dilute it into a bag of fluids. So this 500, that is irrelevant. That means nothing. And then and you can basically, I'm hoping you can tell that, because 500 ml bottle of this fat, heavy solution, when you see that, the 70 should be your trigger of telling you what the C, one of the concentrations is, and whatever number it's telling you is containing that 70%, that is not a number we need to pay attention to at all. It throws it in there to throw you off and, just just because that's how math questions are, right? They're trying to train you. They're trying to get you to see what the numbers are that we care about and what the numbers are that we don't care about. So that's a number we don't care about. We don't care. Now, how many mils will you add to 900 cc's of LRS? So there's another trigger. I have 900 cc's of something that I care about. 900 cc's of LRS. So this dude is my LRS bag. And why I put this additive sticker here is another visual for you. When we start putting a heavy concentrate of something into a diluent in a hospital, we must label that now this bag of LRS has something in it. 50%. And we added however many mil. And it was added by me, and it expires on this date. And that, again, that's a visual of what we do in hospital to explain why this question is important. Because we're going to do this all the time. When you are approached with this question, imagine in your brain, I need to go figure out, 1, do I have 50% dextrose? Do I have 70% dextrose? What the heck dextrose do I have? I can physically grab hold of that and have it in my hand and figure out how many mils am I pulling out of this concentrated bottle to then add to this port to dilute it out into my diluent, which in this particular question, they wanted lactated ringers. And in this particular question, they said, I only have 900 left. So again, imagine you're going to your patient, you're looking at their bag of fluids that's hanging above them, it's running into them, into their IV, and that bag of fluids only has so much left in it, which is what this question is asking. Ooh, got rid of my dextrose. That's what the question is asking. So, we are, again, creating a new concentration. We are diluting out the heavy concentrate, which is this guy here with the 50% or the 70% or whatever heavy number is on that, way down to something low, way down to something like 7%. And they should also, at the end of these questions, say that they are trying to make a blank percent dextrose solution, because you are diluting a concentrate into a diluent, and that always creates a solution. So we know heavy is going into small to create a solution. So if that's a way to think about it, if you've never handled these things before in a hospital situation, that's okay. We're trying to walk you through it right now. So let's move on to the C1V1 equals C2V2. That is the equation you're always going to use when your questions in school on the VTNE in hospital are talking about, I need to take, or I need to make a 5% solution of dextrose for this patient. Sometimes doctors will say, I want a 2.5% solution of dextrose in that patient's fluids. Sometimes they go heavier and they want 7.5% dextrose solution in a patient's IV fluids. But it all starts first with, do you have a fat dose of dextrose somewhere in your hospital? Great, go find it. And when you find it, what is the concentration? Okay, so in this question, it told me my concentration is 70%. Fantastic. So, C1 is concentration number 1. V1 is volume. Oh, I'm sorry, excuse me. I'm not writing this out. C1 is your first concentration, or what I like to call my heavy concentration. And I'm going to write that down as my 70%. So that I can just have that in my brain. And this is how I used to write it out so that I could figure it out, because for some reason this was very it just didn't click. It didn't click until I had done it probably 100 times in the hospital, and then it made sense. All right. Now, somebody told me whatever this C1 is, that means V1, the 1 and the 1, V1 will always be X. That's the unknown variable that we're trying to figure out. That's an unknown volume that I'm going to draw out of this heavy concentration and dilute. So whatever that fat, heavy C1 is, the V1 will always be X. Okay. Now the opposite side is C2, concentration 2. We know that. That is the lower concentration. And in our problem it said 7%, 7% is our lower concentration. Again, C meaning concentration, and the concentrations can be a percent. A concentration can also be a mg per mil. It can be units per mil, it can be mic per mil, it can be KCl, which is milliequivalents per mil. That's what KCl always is as a potassium chloride. So lots of different things mean concentration, but again, in this particular question, when they talk about dextrose, their concentration they're talking about should always be percent. All right? I don't think they're going to change that up now. Anyway, the V2, volume 2, they told us that part. So that's 900 mils are left in this bag that is hanging on my patient. So we only have one unknown variable, and that needs to stay always with the heavy, heavy concentration, or the big number of percent. And then the other two, on the other side of the equation, the C2%, concentration 2 is the lower concentration, the lower percent, which they stated in the math problem as 7%. And V2, the volume that we're using, we know that one as well. It's going to be 900 mils of the LRS that is hanging on my patient. Now, if you math this out, you need to get both sides to quote unquote equal each other, right? That is algebra 101. So I have my here C1 times V1 equals C2 times V2. And I know for a fact that this heavy concentration is the guy that has to leave, because the unknown variable must stay on one side. I cannot move an unknown variable. So I will divide both sides by C1, which will then leave you with this. So I'm hoping this also helps you. Instead of memorizing C1V1 C2V2 and trying to math it out when you're new at this, and maybe you've never even touched these bottles, maybe you memorize a different equation. So what the equation always comes out to be is V1, that volume unknown, which is also known as X, and that's going to equal C2 times V2 divided by C1. And remember, the 2's, we always know what the 2's are. We always know that concentration 2 will be the lower concentration, the smaller number of dextrose we're trying to get. And the volume 2 will always be the volume of fluids being given to the patient. Now, we're not talking about rate. Rate of fluids given to a patient is going to be labeled as mil per hour. How many mil per hour of fluids are we getting? That's different. Get that out of your head. That's not part of this equation. All right? So let's go back over to the actual question now that we have a different equation to work with. Using 500 ml bottle of 70% dextrose, how many mils will you add to 900 mils of LRS to make 7% dextrose solution? Okay? V1, we'll start there. We already know V1 is my unknown volume. That will never change ever. So we're going to, first of all, we'll pick a different color so that it looks different. Here we go. V1 is always X equals. Now what's my C2? C2, I've said, is my lesser concentration. Concentration number 2 in this equation, that's a lower concentration, 7%. All right? And we're going to multiply that times V2. That is our known volume. That is the second volume that has been, or not a second volume, but just really the only volume that they have labeled on there that is going into the patient. Remember how I said in the beginning, they do have 2 volumes on here. Isn't that annoying? That is why we're getting confused on this, because what they're basically telling you is 500 mils is just what that bottle comes as. That heavy concentration of dextrose comes in a bottle of 500 mils. However, as annoying as that is, it is irrelevant to know that it comes as a 500 mil. What we need to know is the volume for my patient. That's what we care about. So we're going to add to 900 mils of LRS. And we know LRS goes to my patient. Okay? So now we add on here, there's 900 mils left in the bag of fluids hanging above my patient that I just walked over to check on. I said, okay, he's got 900 mils left. My doctor wants 7%. Got it. All right, and then according to this equation, now we're dividing by the heavy concentration, or C1, which is 70%. Okay? Now with math, percents will cancel out. And then we go to our calculator. We take 7 times 900 divided by 70. And it says 90 mil. All right, and that's it. That's it. A lot of people go, well, wait, don't I have to do like divided by mg per mil or mg per kit? No, not on this one. We are not adding anything directly to the patient's weight. We are not figuring anything out by the patient's weight. This number is actually calculated by the doctor based on the patient's glucose level in their blood. So that's what this number comes from. So when you feel you need to go farther with this, if this question C1V1 C2V2, it has nothing written in there about kgs or pounds. Again, that's why I think a lot of people and me got confused on this. I said, well, yeah, I got this number, but don't I have to do something with weight? Not on this equation. When you see C1V1, C2V2, you are not figuring out anything by weight. This is just by diluting. You are literally just diluting heavy concentration down to lesser concentration so that we can trickle in a little bit of dextrose over the hours so that the patient's glucose can get a little bit higher and stabilize. So this has nothing to do with weight, and they are giving you 2 volumes at 500 mils up here, super annoying, but that has nothing to do with the equation. They're just telling you that sitting on your shelf is 500 mils worth of a heavy concentrated dextrose. All you care about is the volume that is for my patient. What is the volume my patient has left in their bag of fluids? That is what we care about. All right, thank you.